Chapter 9 introduces us to analytical chemistry, and you're going to find that through your studies in organic chemistry, we use a lot of different types of techniques to analyze compounds, to purify compounds, and to try to figure out what the structure of compounds really is. And so, before we go really far into exploring the types of chemistry of organic molecules, I want to introduce you to some of the analytical techniques that we're going to be using and that you're going to be seeing in the laboratory. So the first one that I want to explore with you, and of course this is going to just be a brief introduction to these particular topics, and we're going to I'm going to kind of fill you in along the way with what you need to know in terms of getting into more in-depth detail about each type of analytical technique. But the first one we're going to explore is chromatography. Now, chromatography, I know many of you may have been introduced to chromatography in general chemistry, but in essence, it involves the separation of compounds. So this is how we look at the purity of compounds. We can purify compounds in certain ways. We can analyze compounds both quantitatively and qualitatively. And it's something that we as organic chemists use on a daily basis. And in essence, chromatography requires both an immobile phase, which is called a stationary phase because it's stationary, and a moving phase, which is called the mobile phase. And you're going to see that there are many types of chromatography that we as organic chemists use. There is thin layer chromatography, which we affectionately call TLC. And in thin layer chromatography, this is a technique that's often used to analyze, the progression of a reaction. We will learn how to use thin layer chromatography later on in the semester. We also have column chromatography. And column chromatography is a way really to purify compounds. You run a big column and you extrude your sample through it. Then there's high pressure liquid chromatography, and this is abbreviated HPLC. And HPLC, again, you can actually quantitatively figure out how much of a substance is in there by separating it from its components. And this is certainly done in the liquid phase. Now, another way of separating components quantitatively is through what's called gas chromatography, or GC. So these two latter techniques are quantitative techniques, whereas the two former techniques, the TLC and column chromatography, are really a qualitative type of process. So let's explore just a little bit more detail HPLC and GC, and I just want to go through kind of the process of each one of them, not in great detail, but just to get you to think about what's really happening in that process. So what you have, here's an image of crude image of an HPLC system where you basically have a column, and in that column, you run solvents through it. So you have some pump, and that pump is pumping solvents through that column and then eluting it into a particular flask. So what you do is you inject your sample onto the column. And now what happens is, so you have a stationary phase, which is some material that's in that column, and then you have a mobile phase, which is your solvent. So the mobile phase is basically pushing your sample through that column. But the sample is interacting with both the mobile phase, your solvent, but it's also interacting with the stationary phase. And depending on the interaction, each compound is going to interact in a different way, and therefore you can separate a variety of compounds and they will elude the column, we call it, at different rates, such that if you have a detector, and typically for HPLC the detector is a UV detector, then you can actually detect it looking at absorbance. And so you see this chromatogram on the right side here. That is an example of what you would see, and those peaks indicate different compounds that are being extruded from the column. Now, in order to identify those compounds, you actually have to have some type of standard in the process to say, okay, this standard is eluting, with this solvent at this particular time. And so doing so, you can actually say, okay, if I know this standard is eluting at this time and I inject my unknown sample, then I can measure the area at that particular time, and based on the concentration of the standard, I can figure out the concentration of that particular compound in an unknown sample. And likewise with GC kind of works the same way, but now instead of talking about a liquid phase, we're talking about the gas phase. And here your carrier, your mobile phase, is a gas. Your stationary phase is some type of solid material. And the process works very similarly, where you inject your sample, and now that sample interacts with the, the material in your column, and of course it's also going to interact with the inert gas at different rates. And you can, with this, if we're talking about a gas phase, we have to keep it, the sample in a gas phase, so we generally heat it up in an oven, and it passes through that column, and different compounds elute at different times, and you basically have a detector at the end. And of course, the detector here can vary. Sometimes you use what's called an FID, flame ionization detector, which essentially combusts the material, or you have a TCD detector, thermocouple detector, which simply looks at the difference in electrical voltage between what's passing through the column and what's passing through as the baseline of your inert gas. And so you can see different variations of that. But again, the chromatogram itself looks very similar to a chromatogram from HPLC. So that's a short little introduction about chromatography and how we use it in our daily organic chemistry lives.